So what's up everyone, we're here today with an Unreal Engine 5 tutorial. It's going to be how to make a game, and the game we're going to make is Snake, and hopefully along the way we learn some basics and you guys get some ideas of how to do certain things like spawning, setting up controls of the controller, and swapping out character mesh, tracking score, things like that. Got the idea just from someone who was having some problems on the Unreal Engine Facebook group, and I was like, I just had my wisdom teeth removed a couple days ago and I'm bored, so let's make Snake. Alright, let's get started. So two things. I'm starting in a third person template instead of a top-down template, and there's a couple reasons for that. The first reason is that I want to be able to control easily with the keypad versus the clicking with the mouse, which is what comes standard with the top-down. And I thought a third-person Snake where you could also switch to a top-down camera view would be a cool idea, especially for our little example project. The other thing I wanted to mention was that I haven't planned this. I haven't like set up a plan or anything, so I'm just doing this pretty much live, so bear with me if we kind of get stuck. And yeah, so you're going to want to get started by opening a third-person template project in Unreal Engine 5. 4 would probably work, but I'm using 5. 5.2 to be specific. I have not updated to the new stuff yet. So first thing we're going to do is I think we should create our Snake character. So in our characters folder, actually no, we're going to go in third-person folder. Actually, let's start our content. Let's create a new folder. I'm going to call this Snek. That's not Snek. Snek. And we're going to create a class. This will be our character. We want it to be a pawn. Character would work, but we don't need to walk. So let's just do a pawn. BP Snek. My teeth kind of hurt, or my gums, I should say, where my teeth used to be, but not too bad. Just noticeable. Alright, what do we want? We want to start with a cube. We're going to keep it simple with our shapes to get started. We'll have this cube. This will be our Snake starting body. Cool. I'm not sure which way is forward, so let's add an arrow component. That'll give us an idea. And it looks like forward is on the x-axis, which is red right here. This is a gizmo. You can see that X is red, Y is green, and Z is blue. So it'll just let us know which way is forward when we get a forward vector, with a forward vector being a direction, and you can multiply vectors by lengths, a scalar, to get, you know, lines in 3D space or 2D space is what we'll be doing. A little vector math pro tip. If they would have told us that we would need that in high school or whenever, it would have actually been interesting, but at the time, not at all. Alright, so we got our Snake class. Let's just throw it in there so we can see it. Open up, right click, do a new blueprint. We want our actor. We're just going to call this to be BP. What do you call those little food points? Snack. Let's call it Snak. Is that too close to Snake? Snek and Snak. I'm going to call it Snak. Not snack, it's a snack. It's a snack, not a snack. Alright, that's enough. And guess what? It's also going to be a cube. Let's make this a sphere, just so we can differentiate. Otherwise, if we had a cube and another cube, it'd be more lore accurate. But anyway, we'll start with sphere. Okay, I'm like off-centered, I'm realizing. I'm like over here in the camera. Should be over here. I'm leaning. Oh well, deal with it. Okay, we got our Snak and we got our Snek. What do we want to do next? I think controls would be good. So let's set up controls. How are we doing on time? Already 4 minutes in, we haven't done anything. So if we go into third-person blueprints and you go into our character, you're going to see we have input mapping. I almost want to start over already and replace our Snek with this third-person character and just delete the mesh but we want a custom movement input. So what we're going to do is we're going to grab this input mapping, copy and paste this. So Control C for copy, go into our Snek, event graph, and we're going to paste this. Apparently we're not going to. We're going to try that again. Paste. We got our input mapping. So this will set up our enhanced player input. If you haven't done that, I got a tutorial on that if you search my stuff. Otherwise, we're going to briefly touch it. Basically, you have enhanced inputs, which if you go into your input folder, we have actions. If you go into IMC default, you have jump, move, and look. We only need move for now, which will be these. So we'll use that. So we don't need camera input right now, but we do need our movement input. So let's take that. I don't even know if this is going to work, honestly, but we'll get there. We'll get there. Okay, where are we at? Enhance input action, I move. Add movement input. Let's just see what happens if we use this. So we're going to want to make sure that our Snak is our default player character. So in this little world settings, can you see that? Yeah. Okay. Where is in game mode? Go down here where it says third person character for our default pawn class. We're going to change that to Snek. Let's just save and see what happens. Okay, now we are inside of our Snek, but we can't move. So how do we fix that? We probably need a movement component. That's just for giggles. Let's do floating pawn. We can't use a character movement component because we're not a character class. I would have done this differently already, but it's okay. Hey, we can move, but we're not attached to our Snek pawn. What do we need? We need a camera. Basically, if you go to our third person character, you can see that we have this camera boom and follow camera. Let's copy this camera boom and follow camera into Snek. My tooth is hurting. I just realized that talking actually kind of hurts my gum. That only pasted the spring arm. Why didn't that paste the follow camera? Copy that as well. Drop that into there. I don't like that. Oops. Make sure you do this. Drag and drop it onto there so it's parented or childed. And we're going to raise the spring arm up by this. And let's give it a little bit of a tilt on the y-axis, which is green. Oh, just kidding. That's weird. Why isn't it rotating? Anyway, so it's kind of ghetto, but you can just rotate the camera a bit and then just move it up a pinch. I don't like that, but just see how it looks. Alright, now when we move, we're attached and we're floating around. Cool. Do we want camera movement? Sure. Let's add camera movement really quick. Let's see what happens. I'm already breaking rules. We might not use camera input on our Snake game, but we're doing a third-person Snake game with the option of going above to a top-down camera. So, yeah. Let's see what happens. Compile and save and see if we get camera movement. Oh yeah. Might as well add jump. I'm just kidding. We're not going to add jump. So there. That's the initial setup of your Snake character. It is bare bones basics right now, and we already spent almost 10 minutes. That's crazy. This is going to take longer than I thought, so I'm going to pause the video here and move to the next steps. Alright, change camera angles. I'm not sure if this is better or worse. We got some weird lighting and TV and bed, whatever. Who cares? We're doing it. Alright. So next thing, when our character's set up, I think we want to limit the movement of our snake so that it works on the grid system. So we're going to probably need a type of loop that will kind of be like a tick. So every like such and such time interval, it'll move our snake in the direction our snake is facing. And also we need to set up the controls to limit the directions our snake can go. So if you press forward, it stays forward, or up technically. Left, it turns left. Right, it turns right by 90 degrees. So we can kind of use this grid as a guide for that. So that sounds like a good next step, and then we'll move on towards picking up the snake food. So first thing is first, in our Snek folder, in our Snek class, Snek. What do we want to do again? Oh no. We want to limit movement, and we want to make it so we only move every tick. Add movement input. Target is pawn. Gives us a world direction. This is left and right, and this is forward and backwards. So let's create an event, and we're gonna break these little guys, and we're gonna hack them. We're gonna get in there, and we're gonna hack them. All right, sounds good to me. Make some space. Let's create a custom event. What do you think? Like movement loop, movement tick, movement loop, movement tick. I don't like the word tick. I'm like, always avoid tick. Let's call it loop. I know I've mentioned it before, but avoid using tick unless you actually know what you're doing and you're controlling the tick intervals and you actually need that thing to run every time on tick, because I see a lot of people and tutorials and examples that use it, or even user interface stuff. It's like, we don't need to refresh the interface every tick. That's insane. Like, you know, like 40, 80 frames a second, or however fast your game's running, like your eye can only see so much. The icon's like this big, you know what I mean? It's not moving much. Anyway, moving right along. Okay, movement loop. Let's use a timeline. Timer. Set timer by event. We'll do that. We'll use a timer. Timer's good. 0 looping. How often do we want it to loop? What do you think the original Snake loop time is? I bet it changes over time. I bet the game starts out slower and gets faster. I think that's how it works. So we're going to make this a variable. So this will be our time interval. And for now, let's do, what do you think? Start at like half a second for now. We'll just do like, that was less than half a second or more than, but we'll see. Okay, drag this out, create a custom event, and I don't know what to call this yet because I don't really know where we're going with it. Let's just say movement things. Okay, so we have that. I like, almost always I like to drag out this return value, promote it to a variable, and this is our movement loop timer handle. That way, if we need to delete or clear this, we have this variable and we can get rid of it. That way you don't have timers ticking in the background all the time like a house of cuckoo clocks going crazy. Okay, movement loop. We're looping every half second and we're going to do things. What do we want to do here? Let's make a comment. Move Snak in direction 1 unit each tick. Okay. But we have this movement input here. So what we want to do is we want to break this. Go bing bong. So what does it need? It needs an action X value and a world direction. So what should we do? We want to grab these. Maybe we just drag that into here and drag that into here and break those. We just do that so we can easily get these variables here so we don't have to make new variables manually. It's just lazy, but it's efficient. Okay, and this will move on left and right. but we don't have these values, and because it's in a loop, it's kind of weird. So when do we want to call this? I don't really want to call this anytime it changes. Or I guess if it doesn't change, it just updates. That's okay too. Let's create variables so we can get them down here. I don't think it's good practice to drag this into here from up here, because this is a separate event and this is always being called. So we're going to make these variables. This is currently not set up for multiplayer, sorry, but that would add too much time to our tutorial. But you can make this multiplayer. It'd be pretty fun. I actually think there's a game like that already on, like, was it like Agar.io or something? Agario. World direction, scale value. So we have these. We want to call movement loop. Movement loop will create this timer, but then it will always be I don't like that. No, that's fine, because we always want this to be okay. So here's what we'll do. We'll use this and we'll check if it's valid. So say is valid. So that means if this timer loop is already a thing, what are we going to do? We're going to branch. If it's already a thing, don't worry about it. If it isn't a thing, let's make it. Because we don't want multiple of the same loop going. So this, once this happens, it's on. It's like always on, which makes sense. It's like tick, but it's a tick that we're controlling the time interval of, and it is a variable. Time interval of 0.5 to start. Oops, not the scale value, my bad. Scale value is a variable that we're setting. This time interval is 0.5. Okay, whoopsie. Okay, so it turns out that it wasn't debugging because I didn't have the Snek spawn versus Snek selected, and anyway, so not sure what I changed in the meantime during that off screen. So we'll take a look. Basically, we're getting the action value. I switched this to triggered because on completed we're getting a 0 value, which you could see when you add these breakpoints. And so we come in here, set our world direction. If movement loop scale value is not 0, then we update it to the new thing and only do the timer loop event if it doesn't exist yet. So then we get our scale value here, and when we do this, say we press right, which is D, you see we're moving a very small amount. That's because every half second it's moving 1 unit. So what we're going to do is multiply that. So in our Snek, grab our scale value and multiply. For now, let's just see what happens if we do 25. I just want to see what we're working with. Hit play, go right. That's really not working the way I thought it would. Unless the movement input is capped. That's a possibility. So this movement input might, yeah, it's usually normalized. Okay. So this won't work. So if we apply a force though, I bet it would pardon my French, would launch us. No. Okay. So we're just doing this wrong because this movement input expects a normalized value, which is between 0 and 1. So even if we multiply it, I'm guessing it's just not going to do that. So what do we want? We want to be able to move our snake a set speed every tick. And movement input just isn't going to do that for us. So we can use a lerp. I mean, we can get mathy with it. What we can do is set world position or transform location. Or maybe just add world offset. Delta location. We need our our location, get self, get world location, kind of lightheaded, guys. I lost a lot of blood. Okay, so we get our world location, we have a direction and a scale value. We're gonna make this 50. So when you have a location, which is, this is a vector direction, you want to multiply this by our scale value. Let's add another pin here. I don't like doing it like this. I like chaining them. Instead of having this 3 here, I would have just done another multiply sign. Remove pin, just do multiply. And doing it this way just because it's easier for my human brain to think like, oh, we multiply that and then you multiply that. Do steps. Easier to debug. Okay, so movement things, add world offset. Let's see if that works. We need our... I don't know if we need our world location if we're just adding an offset. I never use this node. Let's see if it works. Okay. Okay. And that's how we're going to do it. So that's left and right. We don't need this. Let's drag our little boxy. So the way that works is you are surely aware, is we get a scale value, which is either going to be 1 or -1, depending on if it's left or right on the x-axis value from this movement. And then every half second, which is this time interval on this, is looping. If this is not 0, that scale value I mentioned, we're going to multiply that -1 or 1 by 50, which is units, and then we're going to multiply the world direction to move our world offset. So we're here, we go this way or this way. Yeah, cool. Next video, I'm going to take a little breaky. Alright, for this next part, might be as simple as just deleting this and copying and pasting this one in, I hope. Famous last words. Plug those in to their respective pins. Hit play. If I press forward. Okay, make sure you click in the little editor. Left. Wait. Oh no. It only goes forward and backwards. Oh no. So we need different directions. So this is basically overriding our previous one. I'll show you. So if we debug, we're probably just getting the same -1 or 1 on the y value, which is weird, very weird that it does. Like, how does that work then? Yeah, see, it's just gonna be 1. It has a world direction. That should be setting our direction. No Chick-fil-A sauce? Is it working now? We're going forward, let's go right. Oh, I see. So yeah, it is overriding because we're using these. What we could do, there's 2 ways we could do this. We could create a branch here and be like, okay, if we're using an X value, like this is not 0, then execute next code, like a switch. You know what I'm saying? So if this, see how this is 1 and this is 0, we'll filter which one of these we call, or we just create different name variables here and set them differently. But we're going to just use these 2 because we know 1 if we're going left and 1 on this one, 0 if we're not going forward. So we'll use those as a little branching filter thing. So I'm going to create some space. Doing it live. I don't know if you guys are going to learn much doing it live, besides how to debug and build things and maybe think about problems and how to fix them. That's valuable. Okay, so we got action value x. If it equals 0, should we do that? Oops. So if that equals 0, branch, then if it does equal 0, we don't call this one. Excuse me. So what am I saying? If it does equal 0, true, we call we're moving forward. Okay, I'm going to make some space because I don't like the way this is laid out. Drag this down, and I will move this down as well. Oh, very good, Sonny. Oh, let's go. Okay. Then if it doesn't equal 0, we know we are moving left and right. That's all. We don't even need to worry about the y-axis value, I think. Maybe. Because we always want to be moving forward, right? I don't like that. I have a bad feeling about that. Oops. Remove breakpoint. Play. So forward, left, down, right. Cool. That's the basics of the controls for the Snek. Now let's move on to picking up the Snak for the Snek. Let's go. Okay, so for our next part, inside of our Snak, which is our little sphere ball thing that we pick up, it's our pickup thingy. Open it up and delete some of the stuff. When our Snek runs over the sphere, we want to do something, so we need a collider. And what we want to do is increase the speed of the Snek, increase the length of the Snek, and increase the player score. So where's collision? Sphere collision. Ooh. I'm just going to call this collider. If you go to the viewport, you can see that it's not in the right place at all. Put this to 0 and increase the sphere radius. That should do. Let's make it 80. A little wiggle room for our hitbox, because the player's terrible at aiming. Okay. So if you grab a collider and you scroll down on the right as you have it selected, you can go on component, begin, overlap. Hit plus sign on that. So whenever this is overlapped, we do something, or can do something. So let's go say our other actor. We're gonna do a cast to Snek, and if the thing that ran us over is a snake, we'll do something. What do we want to do? First, let's just print. Let's say I'm a Snak. Sorry, I'm bored. Okay, hopped up on ibuprofen and Tylenol. So we also want to destroy actor. And another thing we want to do before that is spawn a new Snak in a new location. Yeah. Whoa. That was weird. Alright. Play. Let's go forward. This is so fast. Right. Forward. It says I'm a Snak, and it was destroyed. Cool. So while we're here, I'm also going to change in the Snek our scale value. Okay, see this where it says 50? Let's just promote that to a variable. We'll call it movement distance and compile. Put that to 100. feel like that'll be better. Probably need to adjust that as we go, but don't worry about it. Close that, we don't need that. Close this. And in our Snak, what's our next move? We're going to create an event inside of our Snak that increases the length of our Snak. So let's say custom event 8 Snak, and we'll do a print string for test purposes. Ooh, make it green-ish, greenish, 5, and Snek 8 Snak. So back in our Snak, we get our other actor that we overlapped. We cast to a Snek to see, is this thing we overlapped a Snek? And if it is, we get this from that Snek we call 8 Snak. Also, fucking pardon my French, but pro tip for you guys, check your casts. Like, do a cast failed print and then say like BP Snak slash sphere overlap slash cast to Snek failed, and then make it red. This way, just as a good practice when you're debugging and you're making more complicated projects that have lots of things going on in casting, if something fails, it will tell you, and you'll find it. It'll be in your log, it'll show up on your screen, it'll help. If you get too big of a project, you don't want to print the screen because then it's just a wall of text and you can't see anything. But pro tip right here, burn this into your memory. It's useful. It saves you a lot of time because it takes like 2 to 10 seconds to do this. Save you minutes, which minutes become hours. Okay, 8 Snak. Spawn a new Snak in a new location. Alright, so we want to spawn a new Snak in a new location. So spawn from class. So some people would create like a Snak manager class, but that's unnecessary unless things start to get complicated. Say you want to spawn a bunch of Snaks at a time, then it would be good to use a Snak manager class. But because we're only going to be spawning one Snak at a time, we can have the Snak spawn the new Snak and then destroy itself. But if you want multiple Snaks and more control, create a separate Snak spawner class and have that spawn the classes, and just do what we did here, where you say, okay, create a reference to that manager class here that is created on spawn, and be like, yo, this one Snak got eaten, handle the logic. But we're not doing that today. We're just keeping it simple. BP Snak. Maybe I should have a snack. I'd feel better. It's almost 3, which means it's almost time for me to eat some Tylenol. Or was it ibuprofen? Oh shit. Okay, spawn transform. So we need a location. Here's the thing. We can't use the Snak's location to do an area around it because we could spawn out of bounds. So we need anywhere in the bounds of this level, which I don't really know what it is. So what we can do is, out of laziness, drag a Snak here, go to details, drag it around. So at 0 on the Y, excuse me. So 0, 0, 0 is this corner. And then it goes all the way to about 3,000. We'll say 3,000, which means it also goes, actually it's not a square. 3,500 roughly. So it's a 3,000 by 3,500 square starting at 0. So now we know the rough dimensions. So in our Snak, let's split this struct pin. You can right click and split it so you have a location. So get random vector, or get random location and navigable radius. The thing about a radius is that it's a circle, but if it's navigable, we could probably use that. So if we find the origin, it's going to be 1500 by 1750. So I'm going to say, let's just promote a variable. Call this map origin, or center of map. So on the X, it was 3000 long, so that's 1500 is the middle, and the other one was 3500, so that's 1750. Z is at 0, probably. I don't know about that actually. Yeah, I think 0 will work. As long as we have a nav radius. The radius is going to be 1500. No, it's actually going to be 1750 because we got to use half of the longest distance for that to work. So there's other ways to do this. I was originally going to use a random point and location, but this will probably work. Famous last words, probably work. So we'll get a random location, navigable radius, which is a sphere. Might actually want to go bigger than this, just to be safe. Let's just say 2000, who cares? That way we don't miss the corners. I'm not sure if they would catch the corners. Anyway, move along, take that random location, put it into our transform, and it will spawn there. Add a breakpoint here, make sure that this is going to work. We got our values. Make sure that we have a nav mesh. I forget what the button is to view your nav mesh. There might be another way to do it. Show, I don't know, I could have sworn it was P or O or something. Oh, really lightheaded. Okay, so anyway, so go into, are we recording? Yeah. Build, Windows. Place actors. Here, what are we doing? We're placing a nav mesh, just search. Nav mesh bounds volume. Drag that into your map. Close that. And you can see it's a cube. It needs to be big. So we're going to say our scale 50, 30. That's not bad. It's kind of big. 25, 20 by 20. Move that. And 5. Okay, so we got our nav mesh inside of our map. You can see that it contains everything. That's what you got to make sure you do that. It is 0 or O. No, it's P. So now you can press P when you have the nav mesh bounds, and it will show you where all the nav mesh is. Problem is, you see these little green spots up here. That means that those snake things will spawn up there potentially, and that's a problem because we can't get to them. But we could fix that. You can either change your nav mesh bounds to be lower than that, or you could clamp the Z value on that vector you get returned from here. You just clamp this Z value. But I think, out of the sake of laziness, I'm just going to make the nav mesh bounds volume be a little smaller too. That'll work. It'll still spawn on top of these, and we can't get to there yet, but we're not going to worry about that because this is just an example map. Okay, remember to press P to get that to work. So now let's press play. Let's test it. So we go forward. I'm going to go right and then forward. bonk. We got to center a map. Return value is true, so we know it worked. Return to location of 826 by 257 at z of 10. We spawn the Snak in that location, and then we destroy ourselves, or the Snak destroys itself. So now there's the new Snak. Cool. Very cool. That's the basics of spawning the Snak. We're going to move on to the next part, which is going to add length to our Snek and probably create like a user interface scoring system. Alright, I just hopped in the shower, got back, grabbed a snack. It's Mott's applesauce because of my teeth, and I like forgot how good this stuff is. So today's sponsors are Mott's applesauce. And Body Armor. Just kidding, I don't have sponsors, but maybe someday, and if it is, Body Armor, sponsor me. And also you guys should make a freaking lower sugar version, possibly carbonated. No one needs this much sugar. You have all this other good stuff. Anyways, moving right along. We're gonna go into the Snek pickup, and we want to increase the length of our Snek when we snack. So in our Snak class, where we do this casting, we're going to call an event 8Snak, which is in our Snek. This is why naming is important, because things can get confusing. Okay, and what do we want to do? We want to increase the length of our thing. So, am I recording? Yeah. Increase length. Sorry, I got one hand. This hand's injured too. I don't know if you can see my wrist. It's all twerked up. Just got all beat up after the last update, dude. Not the only one. Oh, Snek. Alright. 8Snak. Increase length of Snek. How are we going to do that? The way I pictured doing it is just spawning another cube. But then it's like, okay, how do we control the position of the cube? You know what I mean? Yeah, it's like gonna be a delayed offset. Dear God, that's actually, what's the easiest way of doing this, do you think? What do you think? I don't know. If we're using cubes, we're just gonna spawn a new cube. I don't know. Attach a cube. Component. What do you think about component? We have to spawn it. So we would spawn. Can you just spawn a cube, or do you have to actually make a class? You have to make a class. So we're going to run into some issues. The first one is, how do we handle spawning another cube? And then this following issue is when our cube moves and turns, so like moves up and then turns right, this cube needs to follow. So it's like there needs to be some sort of delayed command if these exist separately. If there's a smarter way to do it, which I believe there is, I just don't know what it is off the top of my head, it would act more like a trail, a ribbon. So each piece of the ribbon chain would, you know, act like a particle system. When you move, it just has a delay in movement as well. I'm not sure how to set that up in a simple way off the top of my head, so what I can do is brute force it, and that's just, we spawn the cube behind our current cube, and anytime our cube moves forward, so does the other one. And if our cube moves to the right, depending on the position of our cube in an array, like if it's position 1, it'll wait 1 turn. If it's to go, it'll go forward and then turn right, waiting 1 turn. And then if it's in position 2, it'll wait 2 turns before it takes that turn right command. That's a little complicated, and I'm pretty sure there's an easier way to do it. Again, I don't know what that is, so brute force it is. But first, we just want to spawn. So to do that, we need a class. Alternatively, we just spawn another Snak, but then that'll take inputs, and we don't want that. Do we not want that? Yeah, because otherwise it'll move with it. Okay. Create new class. It's going to be an actor. BP. Snek body. Buddy. Snek buddy. Okay. Drink some water. Let's add a cube. Go into the viewport, move that up 50 units, I think, or is it 40? It's always hard to tell. Looks like 50. Check our Snek. It's up 50, okay. So spawn actor from class in our Snek. Excuse me. What do we call it? Body? Snake body? Snake body. Now we need to know what position. This is where we're going to get a little technical. Only a little bit. Let's split this transform. We don't need rotations because we're cubes. We didn't need scale, so we don't even really need to split the transform, but I like to do that. We need a location. And that location is based off of our cube's location. Get world transform or location. Let's get location. And our, what do you think? Do you think our cube's radius, the width of our cube is 50? That's my guess. Or is it 100? It's 100 because we moved it up 50 and it was centered, so it must be 100. So we're just going to get our world location. We're going to get our world direction. We're going to multiply world direction. This is actually going to be make literal float. Make float. Forget. Make forget. Make literal float. Plug that in. What did I say? 50 is half, so 100. And we want it to be behind, so we're going to invert. Inverse transform direction. Maybe this. I'm wondering if we just multiply this by a negative. Do you think that would work? Maybe. Let's find out. All my vector mathematicians, does multiplying a vector by -1 reverse or inverse it? Probably. It makes sense to me if I don't think about it. Okay, so in the direction behind our cube at a distance of 100, and we have to get our world location. Let's add. And then that is our spawn transform location. This might work, it might not. I don't know, man. Let's hold on to this. This might be useful. Play. Click in here. Let's go forward. Oh yeah, and in our Snek, make sure in our 8 Snak, let's add a breakpoint there just because. Well, it's spawned, but it's not attached. We gotta attach it. So in our Snake, we need to attach. Actor to actor. Actor to component. I don't know if it matters, because technically this cube is a component of our Snek actor. So we could attach to the Snake class itself. I don't know if that's going to matter. Our parent is what? I don't want Here, delete this. We spawn this, drag this out, and say attach. Actor to component. There we go. That is the cube. Did I have that same thing before? Probably. I was just confused. What's the easiest way? Let's move the camera up a pinch. Actually, let's move the spring arm up a pinch. Why is it hitting? It shouldn't be hitting. Maybe it's our arrow. Arrows don't collide. Cube, collision. Ignore visibility, see if that works. Probably not. Voice is leaving me. Alright, we're going at a weird angle. What the hell? It's on top of us. What is going on? What is going on? Might be this. Alright, before doing the negative stuff, am I recording? Yup. Okay, before doing the negative direction stuff, let's just see if we can spawn our cube next to our Snek. To save time, I'm going to move this closer too. Where is it spawning? Way over there. Okay, that is not where we want it to be. Why is it doing that? We get a world location of our cube. We're adding, instead of keep relative, keep world maybe? Is it something dumb like that? Yeah, okay, so it is something dumb like that. That's annoying. So switch this to keep world. Let's get our negative stuff back. Copy paste this. Change this to a -1. And multiply. Sorry this is taking so long. I shouldn't say sorry. I say good job on keeping up with this video. If you guys didn't know, a vector 3 is just 3 floats as one unit, an x, y, and z usually, but it can be anything. Okay. What the hell, man? That's so weird. Math. Alright, let's just add a pin and subtract 50. It might be 25, but I'm going to go with 50. Okay. Minus. Make sure you add the negative sign. Okay, so I'm going to move this closer so it's not so, it doesn't take so long to get to it. That's weird. It was off at an angle. It's ever so slightly off. So here's the problem. If you go left and right once you attach it, which I knew would be our problem, it just moves with you like, and we don't want that. We want it to be like a chain. So that'll be our next step. Actually, maybe we should do something easier first. Okay, I'm fading on here, but let's just think about how we're going to get the cube to move, or the snake body to move properly. And what's coming to my mind is that each cube in the body, if you go back to the tail, it only needs to know about the position of the cube in front of it, the body part, at the previous turn, click, previous tick. So each snake body part needs a reference to the one that is in front of it and its last known position at the previous tick. So it'll be like a chain reaction where going from the Snek head we'll be like, okay, previous one, we'll be like, okay, what was the position in front of me? You know, take that position, and that's where we're moving next. Even though right now we have it set to attach, we can't actually do that. Because, well, we can attach them, but then we'd have to do like a local offset thing, which isn't that big of a deal, I guess. But yeah, so basically, cube, spawn the next body part. This body part will, every tick will ask, okay, what was your previous position? It'll be like, I was here, I'm moving here, and it'll be like, okay, I'm moving here. And then spawn another one, will be here. It will, this will move forward, this will be like, okay, here, and this guy will be like, where's your last position? It was here, okay, move forward. Sorry, I had to look at what my fingers were doing. But you know what I mean? Hope that makes sense. And now it's a matter of making it codable. So we know we need a reference to the attached, the leading body part from each snake body so it can look ahead, and a position. So in order to do that, we're going to go into our snake body. We're going to add, I don't know, Snek reference, snake body reference. And click the little eyeball, expose on spawn. That means we have to keep track of that. That'll be interesting. And we'll just get a location. We'll say previous location. Question is, should this be the location of this one? We'll have to think about that. Less thinky, more doey. So, expose on spawn. Now that I'm doing this, I'm like getting tired. So it's like, why did I start this a couple days after having my wisdom teeth removed? It's like, because I was bored. Okay. And I'm trying to make videos on Friday, and I haven't been very good about it lately. So when our snake spawns a new body, see how we got this body reference? Whew. We need to set this. But I'm actually thinking, should we call this on our snake? Or should we add that to the body and just have whichever last body? Because we need to know. Here's what we'll do. We'll create a variable on our snake. We'll say last body part Snek, last snake body. So we set that variable once we spawn this. Okay, and what we'll do is we'll go like, we'll get it, we'll be like, is this valid? If it is valid, that means it'll be the second. So if it is valid, it means we already set this, so we're on the second loop. So this already exists, and we can say, okay, our last snake body is this one. That'll put this snake body into here. But if it isn't valid because it's the first one we spawned, let's make room. Let's delete this thing. Say like if is not valid first snake body spawning, and just copy paste this. Is it not the same thing? No, it's the same thing, we just don't use the reference. Okay. Is there a better way to do that? Because that's like writing the same thing twice, just this time we don't feed a reference in there. I don't know. That'll probably be okay. I don't like it. It's kind of repetitive. Basically, we're just saying if this doesn't exist, don't plug it in, because that's the first time spawning it. So that's how you check your references right here. This is valid node. So a lot of times in debugging, you'll get null references, which cause problems. Where you're trying to access something that has been destroyed or no longer exists or was never created in the first place, or like if you're doing multiplayer, it can get really confusing. So you got to do these valid checks on references of objects. And as good practice, you put BP in these names so you know that they're blueprint objects. Okay, whew, just saying that, I'm like lightheaded. Bom, bom, bom. Do-do-do. I should rest. Ain't no rest out here, boy. Okay. Yeah, so first time it'll come through here. Let's just test it. It's weird that it moves diagonally sometimes. See how it says unknown? That's because it hasn't been created. That's why I use the is valid check. It'll just create this. This won't have a reference. So for the first one, we just do that. The next ones, we're going to want to call an event on those snakes bodies to get it into the right position. So this spawn transform location, we're not actually going to use this location. We're going to modify that. So if I hit stop, so we want to get the position of this, actually, our last snake. Not the root component, we want the cube. Give us the cube. So we're swapping out because now that this snake cube is valid, we want to get the position of this one and move it behind that one, if that makes sense. So we'll test that really quick. Does that, goes down here, moves it behind our cube we've got. So now, I know the movement's incorrect and the position's off, but we'll fix that. Oh, it's based on our camera, that's why. So yeah, hold on. Problem is with our forward is based on our camera. We need to get rid of that. So this is now valid. You can see that the reference is there. There's everything. So we'll go through here. We'll get our last snake body, which is 0. We'll get that location and we'll attach to that. Hit play. And now we've got 3 cubes. Positions are all out of whack though. That's fun, but at least we're kind of getting there. This is what I get for allowing the camera to do things. We're probably going to disable the camera for now, just to make life easier. Where's the camera input? Just do that. If you do that, then in theory, position's off. Of course, now we can't see anything. So yeah, so now we've got 3. So because we're using world direction to determine where to put that cube right now, it's putting it behind us because we're moving right, so it's just moving it behind, but we'll change that. Add that on the list of things to do, but not worried about it right now. Okay, so now we want to create an event inside of our snake body that'll tell it the previous what do you call it, snake body, where to move. So we're going to call that a custom event, I don't know, update position. And just drag this here for now, or say set. Put that in there and just delete these. That's how you can kind of hack that to save a second. So we're going to set world location Let's just do default scene root because that'll move the cube with it. Set world location and it'll take that position. So in our Snek, I kind of want to not attach because attaching is going to cause problems. And that problem is, as you saw, it'll always be in that position, although we could attach it and then move it relative. So I don't know if it matters. It'll be easier to debug if it's not attached because we'll obviously see that things are going wrong. Okay. What are we doing? We're spawning our snake. Then every time we go through here, we're adding the world offset to what? Our actor. And then, what do you think? There's a lot of ways to do this. Some sort of chain thing would be nice, but what we can do is we can create an array of snake bodies, and then for each item in that array, update their positions based on the one in front of them's previous position. So it's kind of like an array stepping. So that's one way to do it. So let's call it snake bodies. I don't like doing this way, but it's probably how they kind of did it before. I don't know. So now we have an array, but make sure we add each new snake to the snake body. I'm going to say add unique, even though we know they're unique, but let's just, to be sure. Add unique takes more time, but it's not that big of a deal. It just makes sure that you're not adding duplicates, which it won't, but we're just doing it to be safe. Okay, so now we've got our snake array, and on each time this movement thing updates, we'll go for each. This is not super efficient because we're doing a loop through everything each update. I don't like that, but it is what it is. I would prefer that each one just calls one and then each one signals to the one behind it, but this also works. What do we want to do? Update position. But then we have to get the previous location. And we need the previous location of the one in front of us. And to get that, we say get world location cube, get index, no, this, we need to get copy, given this index -1. So index -1 will be like, okay, you have an array, oops, you have an array of like 5 body parts. This is the head, this is 0, this is 1, 2, 3, and 4. If you're at 1 and you want to get the position in front of it, you do 1 minus 1 is 0, so you'll get the position here. And then you're going to update when this moves, you want to move to that position. I just break my finger. So, snap! Anyway, yeah. So we're getting that. Get the world location. I guess I could have just plugged that in there. And that is our previous location. I want to rename that. what do you call it, like forward body, previous location. That's a weird name. So in all of our snake bodies, every time this ticks, we'll move our cube into there, and this will tell our default scene root to move there too. Hopefully it works. Are we calling it? It's being called each time. Okay, let's test. Boom, boom. Go down there. Just debug it really quick. Make sure it's being added to the array. So you can see the array number is 1 and slot 0. We got all our stuff and it's attaching. Bonk. Uh-oh. Can't see anything though. Where do you think it is? Previous location. We have an error. Access none. Trying to get... Oh, okay. Array out of bounds error. So our first value was 0. Duh. So if you're trying to subtract 1 from 0, you're going to get -1, and that just doesn't work. So got to account for that, which is, okay, -1. We'll say not equal to 0. It's true. Means it's greater than 1. If it is equal to 0, we just need to attach it here. Is this the correct? No, it'd be here. So notice that this is our cube's world location with the world direction multiplied and all that. We'll do update position there. This is getting complicated. Yeah, it is. Hit false. So which position, we need to plug that into our body thing. Let's do a breakpoint here just to show that it's working. Do that. We know it's going down there, so I'm going to disable this, or remove it actually. Hit play. Is it less than or equal to 0, or does not equal 0? No, it is 0. So then, oh shit, I did that wrong. If our index, I'm just going to say equals 0 to keep this simple. The double negatives throw me for a loop. If it equals 0 is true, we're going to do this. If it's not equal to 0, meaning it's greater than 0 or less, but technically it won't be less. Let's move all this stuff. This is already tangled. I do not like crossing these lines here, so we'll fix that at some point. Here, I'll do that now. This is just a mess. Tidy up, tighten it up. Maybe we should turn this into a function. Breathe, keep breathing. Okay. We'll tidy this up in a second. So if it's 0, just get our cube's position with world direction and yada yada. If it's not, do this. I don't know why that was returning. What do you mean there's errors? Oh. Plug this in. Okay. Very strange that that shouldn't have even have returned that value anyways. Okay, so we know that this is 1, or 0 I mean. So this should be true. Okay, sheesh. It's weird that it did that. Why is it happening twice? Half a second delay. So let's remove this, or just let's add a breakpoint here so we know that for the next one we'll remove this play. So that's getting called every half second. So if I go up, nice. You know what would be nice is if our camera actually rotated with our thingy. What do you think that other thing is? Problem now is that we can directly turn left and right, which is something we should not be able to do, which was as simple as adding a little Boolean check later. Okay, I'm going to add 2 of these so they're easy to find. Play, go here, go left, positions are updating. Now we went to this other one because it's greater than 1, and this time we should be getting snake bodies position -1, which we're, the last position is here. We're going to get this position, which is 0. Most of you guys probably know how arrays work, but I'm just assuming that not all of you study computer science, or, you know, maybe you're just learning. Oh yeah, we got to disable this because it's going to constantly bug us every half second. Shit, come on. Of course now we can't see. So it's not in the right position, but it's following us, so that's a good start. So we just have to account for the offset of the second position, if that makes sense, because we're getting, what, the cube world location, and we're putting it in that world location. We need this offset here. We should create like a macro out of this or something, because it's just a lot. So what we'll do is take the inverse of the world direction, copy all that, paste it down here, drag that into there. So now we're getting that cube's world location. We're doing that same offset thing we did before to this one, and we're just going to plug that into the position there. For now, to make the camera thing, I don't know why it's bumping into stuff still. Move it higher. Okay. All right. We got movement, kind of got a snake going on. It's not perfect, but it's pretty good. I'm going to pause the video there.